In the last section, we put together our first function with the receiver. Now I want to go back to our document where we had listed out all the different functions that were going to exist inside of this cards project that we're working on. Okay, so here it is right here. So at this point, we actually have put together this print function. Remember that print was supposed to log out the contents of an entire deck of cards. And so we really just successfully put this thing together. So we're off to a pretty good start here. Now I think that we should probably go back up to this first function that we had called newDeck. So newDeck was supposed to create and return a list of playing cards. Remember that this cards component or this deck thing, when we say newDeck right here and we say return a list of playing cards, I'm really very much talking about the actual like ace of spades, two of spades, three of spades, and all that kind of good stuff. So let's create this newDeck function right now and get a better sense of the code inside of it. Okay, so back inside of our deck.go file, right underneath our type declaration, I'm going to create this new newDeck function. So I'm going to say func newDeck and then place my curly braces. Now you'll notice back inside this document right here, we had said that this should create and return a list of playing cards. So we need to make sure that this function right here returns a list of cards, or essentially really returns a deck. Remember that with Go, anytime we want to return a value from a function, we must annotate the function with the type that it returns. And we place that annotation right after the function name. So right after newDeck, we're going to put the word deck, like so. So this is going to tell Go that anytime someone calls newDeck, they are going to return a value of type deck. Okay, now as far as the function receiver here goes, I'm going to ask you, do you think that this function needs a receiver? Well, honestly, I personally think that it does not, because the purpose of this function is to create a new deck. And so if you're calling this thing right here, chances are you are not already working on a new deck. You want to get a deck. You do not yet have one. So we're not going to add any receiver to this function because we only add the receiver when we want to be able to do something like, say, call blah, blah, blah dot method name. Okay, so back over here to newDeck. We're going to follow the same type of pattern that we used back when we put together our previous deck inside of the main function. So inside of here, remember, we created a new deck by placing the type name and then the curly braces. So let's start off there. We'll say cards equals deck curly braces, like so. So this creates a new variable called cards of type deck. And it starts off 100% empty, so no cards inside of it whatsoever. Now remember, we want to eventually have this thing contain all 52 cards like ace of spades, two of spades, and whatnot. So we could take the approach of writing out all 52 card combinations here. So ace of spades, two of spades, but obviously that's going to get really tedious really quick. So I'm going to suggest something a little bit more clever. I think that we should create that empty deck, then we should create two separate slices. One should have a list of all the different suits of cards, and then another should have a list of all the different card values, like ace, 2, 3, 4, 5, 6, 7. Then we can set up two different for loops to iterate through the list of suits and the list of card values. And then we can say that for each combination of suit with each different value, we can create a new card and stick it into the card's deck. So I think that we'll take this approach right here to avoid having to manually type out all 52 different card combinations. Okay, so we're going to first start off by defining our list of card suits and of card values. So we'll say card suits is going to be a slice of string with ace, not ace, but spades, diamonds, hearts, and clubs. Now you'll notice that we are creating this as a slice of strings. We're not making this a deck because a deck is really supposed to be used with actual playing cards. So like an ace of spades, a two of spades, three of spades. What we have right here are just strings, and they're really not supposed to be representative of an actual card. It's like half a card. So we're going to make this just a slice of string. Now, immediately beneath our card suits declaration, we'll make a slice of all the different card values. So we'll say card values, and this should be another slice of type string with things like an ace, 2, 3, 4. Now, of course, this probably should go all the way up to king, but I think that ace, 2, 3, 4 is probably enough for right now, at least enough to test things out. Okay, so we've now got our empty deck, which is this cards variable. We've got a list of all of our different suits and a list of all the different values. So now underneath those, we're going to set up 2 for loops, one nested inside of the other, to iterate through all of our suits and then through all of our cards. And for every combination between these two, we'll add a new card to our cards slice. So we'll say for, and remember the syntax here of a for loop that we iterate through. We already put one together back inside of our main function just a little bit ago. Oh, and here's one to reference right underneath. So we put down for the index and we're going to loop through the suits first. So we'll say for I and suit from the range of card suits, and then we'll iterate through all the different values. So I, or for j and value inside of the range of card values. So then we'll take the card slice, we'll create a new card by joining the string suit and value together and then appending it to the card slice. So we'll say cards equals append onto the card slice a new value of suit and value. So suit plus the string of plus value. Okay. So I know that we just went through this loop very quickly here, but honestly, I am 100% convinced that you probably are already very familiar with syntax that looks just like this. And honestly, this goes more to kind of basic programming rather than anything specific to Go. So we created 2 lists, right? We don't even have to imagine these things as being slices. A lot of the syntax and a lot of the structure inside of Go is a lot of programming stuff that you're probably already used to from other programming languages. So we created 2 lists here. We iterate through each one. And then for every combination of suit and value, we create a new value or a new card right here. So this is going to be like we flipped the order. It should be value and suit. So we take the value that we're iterating over and the suit that we're currently looking at, we join them together with a string, and then we add it into the cards list or the card slice. And then we assign the big result of that back to the variable cards. So again, we're speeding through it, but honestly, I think this is kind of straightforward programming stuff, and you don't need to know a lot about Go to kind of do these sort of basic things. Now, the reason I mention this in particular is that I find that a lot of people who are getting used to Go usually kind of freeze up and go like, oh, this is Go code. It's a new language. I don't know how to do anything with Go. Honestly, Go is kind of vanilla, and there's really not a lot of special features to it. You can use all of your basic programming knowledge and apply it to Go and really put together good programs without a lot of study of the language. Now, of course, things like figuring out types and these receivers and whatnot, yeah, that stuff is new language features. But as far as declaring lists and then iterating over them, I think that you probably know a lot more than you think you might. Okay, so back to our new deck function here. We did the iteration. Now, the very last thing we have to do in here, we have to make sure that we return an actual deck. So remember, we had said that we would return a variable of type deck here. So after we do all the iteration, we need to make sure that we return the card slice. Now, again, kind of basic computer stuff here, basic programming. Yeah, do the iteration, create the slice, and at the very end, make sure you return whatever you created. Now, when we save this file, you might see these 2 errors pop up. They're both saying, hey, you declared these variables, but you never actually used them. So you'll notice that, I and j here, they were the index of every suit and value in both those slices. But of course, we never have to actually use these indices at any point for putting this slice of cards together. So whenever you have some variable that you don't actually have to use, we always replace it with an underscore, which tells Go, hey, we understand that there's a variable here, but we just don't care about it and we don't want to use it. So when we replace both those with underscores and then save the file, both the error messages go away. Okay, so I think they're ready to test this out. So let's flip back over to our main.go file. Inside of here, we're going to do a little bit of cleanup. So I'm going to delete that new card function because we're not going to use that to put decks together anymore. I'm going to clean up where we were appending on a card. And then rather than assigning cards this deck right here that we were making manually, we're going to assign it the result of a function called to new deck, like so. So we'll save this file, and then let's flip over to the terminal and test this thing out. So again, we'll say go run main.go and deck.go. And there we go. So we get a big list of all of our different card combinations. Ace of spades, two of spades, and so on. All right, so I think that we did a pretty good job with this new deck function. Let's take a break and continue with our next function in the next section.